Hello. Today we're going to talk about adding and subtracting rational expressions. First, I'm going to remind you about how we used to add and subtract fractions. First thing we would do is we had to find a least common denominator, and then we would add the tops together. So if I have this problem right here saying 5/6 minus 3/10, I would look at these and say, well, my common denominator will first be 30. And for some of you, remember, a 6 is basically a 2 times 3, and 10 is 2 times 5. So my least common denominator has to have both a 2 and a 3 in it and a 2 and a 5. 30 has a 2 times 3 times 5. Or 6 times 5 is 30, or 2 times 5 is 10, times 3 is 30, either way. So then once we found our least common denominator, we multiplied times whatever we needed. In this case, it'll be a 5 for the first one. And here it'll be a 3 for the second one. So 5 times 5 is now 25/30ths, is the same as 5/6. And 3 times 3 is 9/30ths, is the same as 3/10. Now we can subtract. We'll add or subtract just the top numbers. 30 will stay 30 on the bottom. So 25 minus 9 is 16. And then reduce if we can. In this case, we can both divide top and bottom by 2. That equals 8/15. Okay, so we're going to do the same thing, except we're going to use rational expressions. We're going to follow the exact same rules. It's just going to look a little different. So first thing we need to decide on is our common denominator. The first one has an x squared and a y, so there has to be parts of an x squared and a y in it. And then this one is just a y. Well, I can make them both x squared y's if I multiply here times an x squared. So I'll multiply the top times an x squared. The first one already has an x squared y. I don't have to change anything to the 2. The second one, x times an x squared, is going to be an x cubed. Now, combine these two terms. Add these terms. Or subtract. In other words, a 2 and an x cubed can't be combined. So what we're going to do is just leave it, and let's say this thing equals 2 minus x cubed over, our bottom number won't change, x squared y. And that is how we can add and subtract rational exponents. So the first thing they're going to do is ask you for the least common multiple. The least common multiple is just like the least common denominator. It's just not on the bottom. So one method, instead of having to make all the multiples, is to take each of these and separate it into parts. The least common denominator, or the least common multiple, will have the most of every part. So in other words, this 12 is a 2 times 2 times 3 times a y times y. The 6x will be a 2 times 3 times an x times an x. So if we look at it in parts, look at it just numbers first, our least common multiple, or least common denominator, needs to have all of these numbers. So it needs to have a 2 times 2 times 3 in it. And as far as 6, it has a 2 and a 3. We already have a 2 and a 3. We don't need to add any. We need to have a y and a y in it. And we need to have, which this one has no y's, so we need to have some x and x's in it. So I'm going to put them in order, times x times x. That's going to be what our least common multiple will be. So 2 times 2 times 3 will be a 12. X times x will be an x squared, and y times y is a y squared. Another way you can think about it is, keeping with the parts idea, we've got 2 2's and 1 2. Well, I've got two 2's here, so take the most of them. This has a 3 and that has a 3. They're kind of equal, so we need a 3. X's. I've got two X's. That doesn't have any, so we'll take the most of them. This has two Y's, so we'll take the most of them. Let's try the second one. A little bit more involved. There's 3 of them. So we'll start with 16. 16 is 2 times 2 times 2 times 2. And A times B times B times B. So in our box, we're going to have at least 2 times 2 times 2 times 2, because right now we really don't have anything to start with. We're going to have an A, and we're going to have a B times B times B. Okay? The next one is 5B squared A squared, okay? So we need to have at least a 5 in there. Do we have a 5? No. So we need a 5 in there. We need 2 B's. We have 2 B's. And we need 2 A's. We have 1, so I'm going to add 1 more. Now I'll have a 5, I'll have an A squared, and a B squared. You can kind of see it in this list of parts. 20 is 2 times 2 times 5, A and a C. Do we have 2 2's? Yes, we do. Do we have a 5? Yes, we do. Do we have an A? Yes, we do. And do we have a C? No, so I'm going to add a C. And basically, breaking it down by parts, by putting all these parts into this one box, is another way of finding least common multiples. Or you could say, I had 2 2's with the 16, or I'm sorry, 4 2's with the 16, so there's 4 2's in there. I have 5, so let's throw that one in there. This one has 2 2's. I already have 4 of them in there, and a 5 is just equal to 1. Okay, I've got 1 A, 2 A's, so that's what it's going to be, versus an A. I've got 3 B's, so I'm going to have 3 B's. And I'm going to have 1 C, so I need to have a 1 C. Different ways of looking at this. I'm trying to give you multiple strategies all at one time. It's probably not a great idea. Then combine it all together. 2 times 2 times 2 times 2 times 5 is 80. A times A is A squared, times B times B times B is B cubed, times C. And that is my least common multiple. Now when you get to something like this, rational expressions, we need to factor them to find out the parts. So I can divide out an x out of both of these, and that leaves an x minus 2, comma, and I can factor this one to be an x plus 2 and an x minus 2. So I need to have an x in there. I need to have a x minus 2. And then here, I have an x plus 2. I need an x plus 2. I don't have that in there yet. And an x minus 2 is already there. So this whole thing is going to be my least common multiple. All right, so why are we doing this? The whole reason is so that we can add these rational expressions. First thing you want to do is find your common denominator. We've got a 3 and a 5, b times b. We've got a 3 times 6, or 2 times 3. 3 times, let's just call it 2 times 3 times 3. 2 times 9 makes 18. Times a times b. So I need to have a 2, a 3, a 3, and a 5, an a, and 2 b's. Basically taking the most of all my parts. Multiply all these together, that's going to be 90 ab squared. Another way that's interesting here is that if you identify the parts for the local ones, so I have a 3 and a 5 in there, and 2 b's, what's left over is what you multiply times top and bottom. Kind of interesting. So that's going to be a 6a times 6a on top. So it's kind of handy. 7a times 6a is 42a squared. Plus, what's missing here? We've got the 2 times 3 times 3 times a times, oops, 5 a b b. So we've got the 2 times 3 times 3. We've got the AB. We need to multiply it times 5B. So times 5B here, times 5B up there. And you'll notice you'll have all the parts. So that will make a 5B squared. Next, now that we have the same bottoms on the bottom, we can add the tops. And in this case, you can't add 42a squared plus 5b squared because of the letters are different. So we're just going to leave it as 42a squareds plus 5b squareds all over 90ab squared. And that's your final answer. So if we have something of lots of polynomials on the bottom, find your parts. Your parts are going to be items factored. So let's call this a d plus 2 and a d plus 2. And obviously this is just a d plus 2. So my common denominator will be a d plus 2 squared. Plus over here will be a d plus 2 squared. So what I need to multiply in this is another d plus 2 over d plus 2. So this doesn't change. That stays a 6. But remember, take this 5 and distribute it across those parentheses. So you will have a 5d plus 10. Then you can add these two together. And remember, a 6 can only combine with a regular number, so it's the 6 plus 10. So your final answer will be 5d plus 16 all over d plus 2 squared. Feel free to watch this video again if you need to. Try and grasp one of those ideas that finding least common denominators that works best with you. Good luck. Have a great day.